Hello everyone. So for this video, we will be reviewing some definitions related to circles that you might need while we study about circle theorems. Okay, let's start with radius. So radius is a segment shown from the center of the circle to any point on the circle. Take note, from the center of the circle to any point on the circle. So check the given figure on the right. So let's identify given radius from this circle here. So again, take note that it is a segment from the center to any point on the circle. Okay, so looking here at the given circle, the center of the circle is at point F. Okay, so let's connect it to any point on the circle. So if we connect it with A, we have here radius FA. So let's write. So an example of a radius is segment FA. So another example that you can get from here is segment FM. Okay. And one more, we also have segment FD. Okay. So that's radius. Let's continue. Second one, diameter. So diameter is a segment whose endpoints are on the circle and it passes through the center of the circle. Okay. So note that it is the longest chord, so which we will define after this. So if we check the figure here, we can see that we only have one segment whose endpoints are on the circle and it's also at the same time passing through the center, and that would be your segment AM. Okay, so segment AM is a diameter. Okay, let's continue. So let's have chord. It is a segment joining any 2 points on the circle. So notice that the definition of chord and diameter is similar, except that a diameter passes through the center of a circle. Okay, so that's why we consider the diameter as a chord. In fact, the diameter is the longest chord. So, as an example of chord, we can write AM, segment AM. Okay, so what are other example of chord here? We have BM. Okay, so we're using the same figure. And then one more, we have LM. Okay, let's continue. Let's have number 4. Circumference. It is a distance around the circle. So recall the formula for your circumference. It's 2 pi r. Okay, the fifth one, arc. Arc is a portion of the circumference of a circle. So a portion, just a part of the circumference of a circle. So we can find a lot of arcs here. So we can have, for example, arc AB here. This one. Okay, this one is an arc. You can also have LD. Okay, that's also an arc. BM, AL, DM. Okay, can be DMB. Okay, those are all example of arcs. So let's write some. So we can have arc AB. So to name it, you put a curve on top of it. Okay, then we have LD. Then you can also name it using three letters. You can say arc L D M. Okay, so this is arc LDM. So if you want to check how it looks like, this is arc LDM. Okay. Okay. So the next three terms are the three different kinds of arcs. So let's start with a semicircle. So it is an arc measuring half of the circumference of a circle. So to identify semicircle, note that the diameter of a circle divides the circle into two semicircles. So we um, name semicircles using three letters. So let's look again at the given figure on the left. Okay, so our diameter again is AM. Okay, so from there we can form two semicircles. So let's write those. So we have arc ABM, this side here. Okay, okay. So this is a semicircle. So write ABM and put that curve on top. Okay, so on the other side of diameter AM, we have this semicircle. So as you notice, you can see four letters there, right? ALDM. So you don't need to write those four letters. Instead, you can just pick one letter in the middle of A and M. So you can name this side as either arc A L M, okay, or arc ADM. They're just the same, okay? So you can just pick one from ALM or ADM. Okay, let's have the next one, minor arc. It is an arc of a circle that measures less than a semicircle. So less than a semicircle, less than half a circle, or less than 180 degrees. So it's quite easy to identify minor arc. So if you look at the figure, should be shorter than a semicircle. So here we can have AB. Okay, so our AB here is a minor arc. BM, okay, AL, LD, DM, they are all minor arcs. So let's write some of them. We have AB, then BM, okay, arc LD, arc DM, what more? Arc AL, then we can also have arc AD, this one, okay. You can also write that as arc ALD if you want to. Then arc LM also. Or you can also name it as arc LDM. Okay. Next, let's have the last one for the different kinds of arcs. Major arc. So it is an arc of a circle that measures greater than a semicircle. So meaning should be greater than 180 degrees. Okay. So looking here, we know that ABM is a semicircle. So we need something greater than that. So we will just add one more arc, a portion of an arc to create a major arc. So like for example, let's just erase the lines that we have now because kind of confusing now with too much lines. Okay, so here, so as you can see this one, right? So if you have A, B, M, this is a semicircle. So again, it should be greater than a semicircle. So we will add an arc here, a minor arc, to produce a major arc. So here we have A, B, M, D, right? So again, just choose 3 letters, okay, to name the major arc. So we can write either arc A, B, D, okay, A, B, D can be that one. Or you can name it also as arc AMD. They're the same, okay? Or arc AMD. Okay. Now, we can also have what more? If we use the other side of the diameter, the other semicircle, like arc ALM, right? Arc ALM is a semicircle. So if we add a minor arc, then we will produce a major arc. So let's erase this one again. Okay. So this time, we will be using this side. So if we have a arc ALM, okay, so we will just add one minor arc, this one, and we now have another major arc. So if we name that, that would be, we can name it as ADB. Okay, there's a lot of ways to name it. Or you can name it as AMB. Okay. Or I won't write anymore, ALB. Okay. There's a lot of ways to name it. So aside from that, we can still have more major arc out of this one. We can have going to another direction. We can have MA arc MAB. Okay. So, or you can name that as arc MLB. So a lot more. So again, just make sure that when you produce a major arc, so base it from your semicircle, just add one minor arc, can be 2 minor arcs also, as long as it won't be the whole circle yet. Okay, then that is your major arc. Okay, now let's have tangent line and secant line. So tangent line intersect the circle at exactly 1 point, while secant line intersect the circle at exactly 2 points. So from our given figure here, we can simply identify tangent lines. Tangent line here, this line AK. Okay, so you can see this one. Okay, as you can see, it touches the circle at exactly 1 point. So therefore, line AK, so put the symbol of line on top. Okay, line AK here is a tangent line, while secant line, of course, it should intersect the circle at 2 points. So we have here line LM, which intersect the circle at 2 points, at point L and M. Okay, so line LM is our secant line. Okay, next is central angle. So a central angle is an angle whose vertex is at the center of the circle and 2 radii as its side. So Um, which one is the important thing you need to remember? So the vertex should be at the center of the circle, and the side should be the radius. Okay, so if we look here, so we need to take note that the vertex is the center, so it should be F, point F there, and the sides of your angle should be the radius. So looking here, we can have angle DFM. Okay, so we have angle DFM. So the center is, the vertex is at F, and then the legs are FD and FM, and they are radii. Okay, what are other central angle here? You can also have AFD. Okay, so same thing, vertex is at F, and then AF and FD are legs, and they are radius. So therefore, they are also central angles, angle AFD. Okay, are there other more? Okay, now let's have inscribed angle. So inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of a circle. So this time we have the vertex should be on the circle, okay, and the sides contains the chords of the circle. Okay, so now let's go back to the given figure and find some inscribed angles there. Okay, I'll erase it again first. Okay, so the vertex should be on the circle, so we can use M. Okay, if you see point M is on the circle, and then find two chords. Okay, so we can have a M and BM. They are both chords, and as you can see, the vertex is point F, point M, which is on the circle. So therefore, angle AMB is an inscribed angle. Okay, what are other inscribed angle here? So we can also have um, LMA, angle LMA. So same thing, vertex is on the circle at point M, and then the sides of the angles are chords AM and LM. So therefore, angle AML is also an inscribed angle. You can also write angle BML, okay? So the combination of the two, the first two angle that we got. So we can write angle BML. Okay. Okay. Next, intercepted arc. So the arc that lies in the interior of an angle and has endpoints on the angle. Or in short, it is the arc bounded by the endpoints of an angle. So, for example, if you are asked to identify the intercepted arc of, let's say, angle AMB. Okay, let's mark it. So here is your angle AMB. Now the question is, what is the intercepted arc of angle AMB? So your answer should be, so what's the arc bounded by the endpoints of your angle. So if you check here, it is arc AB. So therefore, your intercepted arc is arc AB. Simple as that. Let's have another one. So for example, you have mm, angle DFM. Okay, this one here. Okay, so what is the intercepted arc of that angle? So check the endpoints of the angle, and that would be the name of the arc or the intercepted arc. Okay, so here we have, of course, that is arc DM. Okay, you can simply identify it by checking the name of the angle. So if you have AMB, the first and the last letter will be the name of the arc, since it is the endpoints of the angle. Okay, like this. See, AB, DM, like that. Okay, let's have the last one. Sector of a circle. So the region bounded by an arc of a circle and the two radii to the endpoints. So as you see, this is similar when you have like a pizza, right? So when you get one slice from that pizza, that slice is a sector. So here from our figure here, okay? So we can have this part here. Let's color it, okay? Okay. So this one is considered as a sector. As you can see, it is bounded by an arc, arc DM, okay? And the two radii. So we have two radius here, FD and FM. Okay. So how do we name this one? We can call this one a sector DFM. Okay, DFM. What are other sector here? We can also have um, this part here. Okay, so that blue one, that blue part there, we can name it as sector AFD. Okay, so again, just always check. It should be bounded by an arc and the two radii to the endpoints. Okay, and that is sector. Okay, so just that's it for this video. After this video, we will be starting to discuss about different circle theorems. So these definitions that we have today would help you, okay, understand the theorems easier. So thank you for watching the video. Bye.